first order systems are in series. It may be in interactive fashion or it may be in a non-interactive one. And then second was the when they are inherently second order system, means when they will follow the equation like Newton's law. Force is equal to rate of change of momentum. F is equal to ma. Okay. And the third one was if when the system, the process system is connected with the controller itself. Okay, when we implement the control strategy, it may be a feedback control, it may be a feed forward type of system. When they come into the closed system, then they behave like a multi-capacity system, and they behave like a higher order system. Okay, then we have identified that this is this white board is visible to you? One note.
Yes, sir.
Okay, so in this we have again identified that to analyze it. This one was what with the qualitative way we are discussing here. The control system is nothing but the response. Initially, we identified the response. For to identify the response, we generate the transfer function. Transfer function is nothing but the relationship between the input and output. So in the second order system, we have observed that the equation becomes this one. Okay, so ys is equal to 1 upon tau s tau square upon s minus p1 s minus p2. Okay, so irrespective of that yt, irrespective of that xt, okay, this is the 1 upon x, है ना? So xt, if for a step change it is a 1, then for xs it will be 1 by s. So irrespective of this change, it may be a step change, sinusoidal, ramp, or linear, or impulse. So actually, this ys is depend on the quadratic solution of the quadratic equation which is in the denominator, which is in terms of s. Okay, so tau square s square plus 2 xi tau s plus 1 is equal to 0. It gives us the poles. We call it the poles. That is P1 and P2. Okay, for the quadratic equations, these P1 and P2 are nothing but the solution which will satisfy this particular equation. Okay, tau square s square. Now, yt is a function of P1 and P2. When we implement the formula of quadratic solution of the roots of the quadratic equation, है ना, minus b plus minus under root p square minus 4ac upon twice a. So you observe that P1 and P2 will be of formula of this you will get P1 and P2. So P1 and P2 is the function of xi, damping factor. Okay, now I am comparing this xi with the 1, with 1. So based on that things we can characterize it as like when xi is greater than 1, we call it as a that time when xi is greater than 1, that time whatever the roots you will get, that roots will be two distinct and real poles. That time the response will be non-oscillatory, and this situation is called as, this response is called overdamped response. Similarly, if the xi is equal to 1, if you put the xi is equal to 1 over here, the real and equal roots you will get, and the response is called as critically damped. And this situation particularly come across, you will observe that when the system is in series, just like in our interacting and non-interacting. Why? Because see the poles, two distinct and real poles are real and equal poles. Okay, poles means the roots. We are talking about these P1 and P2, the roots of this particular quadratic expression. Okay, so ये कब मिलेगा आपको? ये कब मिलेगा? When we talking about the multi-capacity processes. See here, है ना? This C I have explained earlier. This one, S1 and S2 are P1 and P2. These are the two roots. These are the two roots, real and distinct. Okay, tau 1 and tau different है तो. If tau 1 and tau 2 अगर same है, tau 1 and tau 2 is equal to tau है तो it will like tau. and this will like 1 upon tau. If tau1, if tau1 is equal to tau2 is equal to tau. So this time, this we can say that the response may be a critically damped, and this time ये response क्या हो गया, ये critically damped हो गया. और ये response कौन सा हो गया? This will be the over damped. Are you getting my point? This time, these two situations, okay, because two distinct poles, distinct and real poles, real and equal poles, you will observe when xi is equal to 1. So ये situations कब arise होती है? When the systems are in series. Okay. Now we will compare it with the now. What will happen if xi is equal to less than 1? What will happen? Xi is equal to less than 1. Under root terms will be negative. So when it will come like a negative, so it will come into the complex number. Agree? So complex number, when we put it into P1 and P2 as a roots in this further yt, whatever the yt you will get, हमें इसको इनवर्स लैप्लास वगैरह करना पड़ेगा, तो उसमें क्या आता है, पीरियोडिक फंक्शन आता है. Okay, and it will give us the oscillatory moment to that response, and such situation, that such response is called as underdamped system. Okay, and this particular underdamped system is observed when the system is connected with, if this is the my tank is connected with the controller system. तो हमारा feedback loop है ना, तो feedback loop में when we use the control strategy of feedback or feed forward, that time the system behave like a complex, behave like a underdamped system. Are you getting my point? We will discuss that thing. यहाँ तक ठीक है, समझ में आ गया? Everyone, is this okay? Please respond.
Yes, sir.
Okay, so now we'll move. Now, so as far as this particular system concerned, we'll see the final form of yt, that is the response for every case. Okay, so see here, we have already compared this damping factor. Now, see here, when we say the overdamped response, it will like this. This is the yt expression. Okay, on inverse of that equation, but this is a step change. Huh? This is the response for step change. This is response for step change. Step change. This is for step change. Huh? Unit step change. This is for unit step change. The yt will be, after inversing it, you will get this type of format. Okay, and its nature will be at 0 to 1, if I would say the unit step change. So yt will be okay if this is psi1 and if this is psi2, if this is psi2. So that time psi2 is greater than psi1 and both are greater than 1. ठीक है, तो इसका मतलब क्या है, जैसे जैसे झाई की फैक्टर, झाई डायनेमिक, दैट इज द डैम्पिंग फैक्टर is increasing. Okay, so it speed or its response becomes more and more sluggish, more overdamped. We call it as a more overdamped system. Okay, overdamped response resembles to little the response of the first order system in series, step of unit step change. But when compared to the first order response, notice that the system initially delays to respond and then its response is rather sluggish. It becomes more sluggish as xi increases or heavily overdamped. Okay, so this is what the statement represent, that when the damping factor, actually it is more the damping factor, more sluggish will be the response. Larger is the damping factor, more sluggish will be the response. Agree? Is this clear? It is just comparing the thing. So generally it is observed that when the multi-capacity system come to picture. ठीक है, रिमेंबर आपको ये इक्वेशंस आपको याद रखने हैं फॉर द स्टेप चेंज, याद रखना पड़ेगा फॉर द ओवरडैम्प रिस्पांस. ठीक है, yt विल बी लाइक दिस. ठीक है, अब yt का एक्सप्रेशन कैसे आया, यू नो. ठीक है, क्योंकि आई हैव ys दिस इक्वेशन, फ्रॉम दिस इक्वेशन मैंने स्टेप चेंज डाला है. Okay, and then I use all the partial fractions and the p1 p2 values, and so I got this right. Okay, you will get at any in the books this expression. Okay, I'm not going into the mathematical arrangement and rearrangement of how to derive yt from ys. Okay, this is very already we have number of times we have derived it. Next is case 2, when critically damped response. What is the critically damped response? When xi is equal to 1. Okay, that time yt will be 1 minus 1 plus t by tau e raised to power t minus tau. Okay, ठीक है, again there is no oscillation at all. So comparatively overdamped system, critically damped response reached the final value, the ultimate value, okay, value faster than that of the overdamped one. ठीक है, ये ओवरडैम्प से फास्ट होता है क्रिटिकल डैम्प when we compare the two situations, the overdamp system and critical damp system. तो critically damp में क्या होता है कि whatever the change, the yt, that is the response is faster than that of the ultimate change, than that of the response of a overdamp system. ठीक है, but both are non oscillatory, oscillations नहीं है. ठीक है, oscillations नहीं है. ये change है मेरा 0 to 1 में, the input में, but yt will behave like a this way. ये yt है, yt का कर्व है, और ये जो कर्व रहेगा हमारा, इसमें xt का कर्व कौन सा है, इटसेल्फ ये है हमारा, ये ब्लू लाइन जो है मेरी, ये है हमारा xt. एक ही ग्राफ में हम निकाल सकते. xt ऐसे चेंज हो रहा है 0 to 1 में. ठीक है, तो yt y को कैसे अप्रोच करेगा, इन दिस फैशन. ठीक है, तो यहाँ ऑसिलेशंस नहीं है, ऑसिलेशंस नहीं है, इट इज अ नॉन ऑसिलेटर. एग्री? ओके, दिस वन इज अ नॉन ऑसिलेटर. Okay, next is underdamped response. So as per the underdamped response, it is something what we call when the system is associated with the controller loop. Okay, control loop. That time the system, the first order system or the lower order systems will behave like a whole overall transfer function comes to be a higher order, that is a second order system. Okay, so this particular equation represent that when the system is subjected to the change in the input as a unit step change, and if its high is less than 1, there is the damping parameter, that is damping coefficient factor is less than 1, that time the yt will behave like this expression. Okay, and this expression gives us this oscillatory motion. Oscillatory motion. Okay, now we will discuss that oscillations, because that very common example, very common situations, the chemical engineering, chemical process industries experience such type of underdamped responses. So we will discuss in details about the underdamped response. यहाँ तक समझ में आ गया सेकंड ऑर्डर सिस्टम का? तीन सिचुएशंस है. तीन सिचुएशंस है which is based on the psi. Okay, damping factor, over damp, critically damp, under damp. ठीक है, over damp, under damp, multi capacity systems, you observe that over damp, critically damp, एंड अंडर डैम सिस्टम कब आता है? जब उसमें हम कंट्रोल सिस्टम लगाते हैं. हम डिस्कस करेंगे, इसके बारे में डिस्कस करेंगे, मगर कब करेंगे? जब हम कंट्रोलर लॉजिक के बारे में डिस्कस करेंगे. कंट्रोलर किस पर्टिकुलर लॉजिक को, विच पर्टिकुलर कंट्रोल लॉ इट इज यूजिंग, and based on that things we will develop a overall control system. Okay, so before to move on this, we will discuss about the underdamped response and its characteristics. Okay, so characteristics, yes, I. तो देखिए, let me tell you, ये जो expression है, this expression gives us information about कि this will be the oscillatory one. If you plot the graph, see here, this equation yt is equal to 1 minus and all these things. When we substitute psi is equal to say 0.8 and just tau को हम fix कर देते हैं say 2, and what will be the variable? Only t will be the variable. Okay, substitute different values of t and identify the graph, identify the profile. Okay, so you observe that such type of graphs you will observe. Okay, these are the combinations of overdamp, critically damp and underdamped system. So these are the different values of psi. If you observe, when psi is equal to 1, see here, this particular, when psi is equal to 1, it is like this. What does it mean? It is not crossing the ultimate change. What is the ultimate change? 0 to 1 is ultimate change. It is not crossing the ultimate value. Okay, it is not crossing the ultimate value. Just a minute. Is this visible?
Yes, sir.
हाँ, अब देखिए क्या है. देखिए, just we are comparing the what will happen if psi is changing. How, what is the effect of damping factor on the response? Okay, when psi was 1, see this line will give us the yt response or the nature of yt. Okay, So this represent that it will never cross the ultimate change. Okay, and asymptotically it will follow that ultimate change over here infinitely. Okay, with the progress of time. With progress of time, it will never cross it. So it is called as critically damped. Okay, critically damped. And when we talk about the overdamped system, we talk about the overdamped system. I'm using different color now, right? It is greater than 1. So you observe that its damping is increasing. That is, the damping factor is increasing. So it is becoming more sluggish. It is comparatively than that of the blue line. The red line is well below at every point of the time. Okay, it represents that it is sluggish. It is slower than that of the critically damped system. See 1.4 also. It is also like this. The S-shaped curve lying below the when xi is equal to 1. Okay, always when xi is greater than 1, it will be more and more sluggish. Agree? Okay, now let's compare the other side. What will happen if xi is less than 1? See here 0.8, 0.6, and 0.4 and 0.2 graphs are there, lines are there. So that time you observe that this line, see, its response is more faster than the critically and overdamped system. They are lying above this particular whitish graph of when xi was 1 and xi was 1.2. Always. But you observe that it crossing at some point. See here at this point. It is crossing the ultimate change. It is reaching the ultimate change, and again it move further as it crossing its ultimate change. But you ultimate observe that it is again returning back to its the ultimate change. Further, a little again increasing, say 0.6. 0.6, again you observe that it is more faster than the initial one. That was when it was zero point 0.8. Okay, it is reaching the ultimate change very faster or earlier than that of the comparatively to 0 0.8, and it is shooting its value greater than that of the previous one. See here, इसकी maximum value क्या है? It is comparatively ये इसकी maximum value से ज्यादा ही है 0.8 के. Okay, but again it is reaching the ultimate value. ठीक है. Further, I'm talking about the last one, the continuous, this one, this graph. See here, when I was 0.2, what will happen? It will reach the ultimate value, but it will cross it and it will jump up to say 1.45 or 1.5. It is 1.5, above 1.5. Expected change, that is ultimate change, is 1. Okay, but it reach up to 1.5, and again it in coming back. Again it will go down below the ultimate change, but again it will reach to the change and again cross it. But if you observe that the amplitude in the next peak is less than that of the previous one, that is what we call it is a decreasing amplitude. It will oscillate about ultimate change with decreasing amplitude when xi is less than 1 in the underdamped system. In the underdamped system. So this is the what we call the observations. Observations, you see, from graphically we are discussing the things, but now you can imagine what will happen if this particular y is my concentration, or it may be a height, of the liquid in the tank, what will happen? Height को अगर हम इसको मानते हैं, height as a liquid height, liquid head in the tank, liquid head in the tank. अगर मैं liquid head करता हूं इसको, so what will happen? It will, if it is under dam and this is its mean condition, then it will behave like this. The height will behave like this. यहाँ से start होगी height and it will behave like this. And there is a possibility that at this point it will get overflow. It is reaching the height above the wall of the container. Then it will get overflow. Are you getting my point? So there is an advantage and disadvantage. Advantage क्या है कि it is reaching the ultimate change very fast, but it will never stay there. It will cross the ultimate change. It will reach to the peak, and that peak may cause difficulty. वो temperature भी हो सकता है. It may be a temperature even. A temperature कुछ ज्यादा हो जाए तो there is a possibility that the reaction inside or the product inside or the reactants inside may get denatured because of the high temperature. And because of that, yield may get denatured. May affect the quality of the yield. तो ये height भी हो सकती है, ये temperature भी हो सकता है, ये flow भी हो सकता है, ये concentration भी हो सकता है. Are you getting my point? Therefore, the analysis and the nature is very much important. What will happen if I am facing such type of situation? That's why implementation of the control, specific values need to be input over there. What should be desired? Are you getting my point? Are you getting my point? Hmm? ठीक है? So this will the fashion we need to study before to direct start the experimentations. है ना? इससे क्या हो सकता है? इससे accidents हो सकते, टेम्परेचर बढ़ना, सडन टेम्परेचर बढ़ना, है ना? So it is a cause of because of some accident. अब मान लीजिए कि लिक्विड हेड इट इज एसिड. इफ इट इज एसिड, अगर वो ओवरफ्लो हो रहा है, प्रॉब्लम होगा, एक्सीडेंट होगा. टेम्परेचर है तो एक्सप्लोजन हो सकता है. अगर वहां हाईली इन्फ्लेमेबल कुछ कंटेंट है आजू बाजू में, इट में गेट कैच, है ना, इट में गेट कैच फायर. एग्री, है ना? तो लाइकवाइज we need this information how that particular variable will behave if it is subjected some type of change like step change and its high value. Agree? Got it? Now so the characterization, uh, to study the analysis, as we have discussed very roughly that this will behave like that if size changes. Now we will discuss about, because this is a very common thing, very common nature we observe into the chemical process industries. Therefore, we need to identify its nature by describing its characteristics. What are their characteristics? How they are behaving? Okay, just like sine waves के characteristics होते हैं. The same thing is for the underdam system. We will discuss its characteristics. Now, students, remember this diagram. Okay, remember this diagram. Ki Y minimum represent that the system is at steady state. Is this visible? Is this visible?
Yes, sir.
ठीक है, y minimum represent that कि at time t is equal to 0, that y minimum means it was at steady state there, and y ultimate is represent that y minimum to y ultimate means ये change input में आ चुका है xt में, ठीक है. I am using on y axis is a y values, ठीक है, and it is a small y represent that actual values, not the deviation variable. Okay, you can represent it by the deviation variable even. Okay, because the behavior or the nature will be the same, only the magnitude will be changed. Agree? So what will happen? The step change and as well as under dam system when size less than 1. So that I'm talking about level now. ठीक है, मैं एक 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 वेरिएबल ले रहा हूँ लेवल, लिक्विड लेवल. तो लिक्विड लेवल धीरे धीरे it will rise, it will reach the ultimate value, but it will not stay there. It will go further. It will reach to the peak. It represented as a y max, and further again it will come to the ultimate value, but again it will not rest over here. It will go down further, and again it will go in this fashion in the oscillatory manner. We call it as a the oscillations with decreasing amplitude, and further it will reach to its ultimate value. See here. See here. So this will be the nature of the response of the liquid which is facing the step change in the input, and it is a underdam system. Okay. So second order control system for step forcing function. Agree? So we will discuss the characteristics of this nature underdam system by defining some terms. Okay, just to identify its geometry, ki above the ultimate value up to the peak it is a magnitude. Okay, from the ultimate to y minimum it is a b magnitude. Okay, so peak to peak is called as period. Okay, successive amplitude height from the ultimate is c. At very first time it is reaching the ultimate value, it is called as rise time. Okay, and plus minus 5%, if it is fluctuating about its plus minus 5%, that is called as response time. Okay, just remember or draw it and on your paper and keep it with you. We will discussing these things, and in the examination even we need this diagram proper. Okay, इसको याद करके रखना है A B C का sequence and all these things. Are you getting my point? इस diagram को आपको याद रखना है, because number of times when you will solve the paper or the numericals, this will give you the it will help to you solve the numerical. Fine. Now, what are the different characteristics? The following terms are defined to describe. Following terms are defined to describe the underdamped second order control system for a step forcing function. Okay. So, irrespective of any other derivations, we are directly using, we can derive it, all the equations. See, whatever the equations you are now watching over here, we can derive it, but we don't want to derive it. Okay, we will use it as it is. Overshoot, it is a measure. What is overshoot? Okay, remember, very first is overshoot. It is a measure of how much the response exceeds the ultimate value. जो peak आपको very first peak दिख रहा है, this peak. Is this visible diagram? Little bit. Students?
So,
Like shape is visible, but writings are not visible.
Yes. What?
The shape of graph is visible, but what's written on the graph is not visible.
Oh, fine. Nah. The previous one is the same graph. This one. That's why I'm suggested you that you just draw it fast. Okay, just remember, na, or draw it.
Yes.
Take pen and paper and draw it. So ABC sequence you remember. ABC. Okay, now we can correlate it with this small, that same image I have pasted over here. Okay, so it is a measure of how much the response exceeds the ultimate value and it is expressed as the ratio A by B as shown in figure. तो A क्या है? Ultimate value के ऊपर है up to peak और B क्या है? From ultimate to Y minimum, Y minimum to Y ultimate value. Is this is A and this is B magnitude. ठीक है? तो ये क्या करता है? It is a measure of how much the response exceeds the ultimate value. Ultimate value, the change ultimate value is here, and how much it will reach up to the y max. This is the nothing but the ratio of a by b. It is called as overshoot. It is called as overshoot. It is formula is e raised to the power minus pi xi by under root 1 minus xi square. ठीक है? I'm not going to derive it. But remember this formula, overshoot A by B is equal to e raised to the power minus pi xi by under root 1 minus xi square. Fine. Where is A? A is above the ultimate up to the peak. Where is B? B is nothing but the difference between Y ultimate and Y minimum. ठीक है? It is between the distance between the Y ultimate and Y minimum. ठीक है? Agree? अब A और B का लोकेशन पता है आपको? ज्योमेट्रिकली यू कैन आइडेंटिफाई ग्राफ अगर प्लॉट कर देते हैं तो इतने यूनिट्स ए के हैं इतने यूनिट्स बी के हैं टेक द रेशियो दिस विल गिव अस ओवरशूट इज दिस ओके ठीक है नाउ नेक्स्ट इज डीके रेशियो व्हाट इज डीके रेशियो डीके रेशियो रिप्रेजेंट इट इज द रेशियो ऑफ साइजेस ऑफ सक्सेसिव पीक दैट इज सी बाय ए ये क्या है कंपैरिजन है देखो ए पोजीशन ये है बी ये है और सी है नेक्स्ट पीक ठीक है तो डीके रेशियो क्या कहता है कि इट इज द रेशियो ऑफ साइजेस ऑफ द सक्सेसिव पिक्स यानी ये जो डिक्रीज ऑफ एम्पलीट्यूड हो रहा है इस इन व्हाट रेशियो इट इज डिक्रीजिंग तो इट इज ओनली द सी बाय ए वैल्यू सी डिवाइडेड बाय ए सी डिवाइडेड बाय ए अगर आपको नहीं दिख रहा है तो अगेन आई एम टेकिंग यू बैक सी डिवाइडेड बाय ए इट इज द डीके रेशियो सी डिवाइडेड बाय ए is a decay ratio. What was overshoot? A by B. Overshoot was A by B. It is e raised to the power minus pi xi by under root 1 minus xi square. Agree? And what is decay ratio? Decay ratio is the